Good morning, everyone, and welcome to our today's online seminar about our installed wireless range. We are explaining hidden features and real advantages. Please welcome Harald Steindl. He's our business development and consultants liaison person at Audio-Technica EMEA. And Harald will talk you through the technical topic. I'm gonna make housekeeping and are responsible to share your questions at the very end of the webinar with Harald, so he can explain them or answer them. So in regards to housekeeping, please use the question and answer section, which you should see in your dashboard, and type in all the questions occurring throughout the online seminar, and we're gonna answer them at the very end. So I'm handing over now to Harald and enjoy.
Hello, good morning, good afternoon, good evening. My name is Harald Steindl. I'm in this meeting from Vienna, Austria, from the heart of Europe. I welcome everybody also from my side to this webinar. I call it masterclass, but you can feel free to call whatever you want. It's about Audio-Technica wireless systems, especially about the System 20 Pro and the ESW, the Engineered Sound Wireless. This webinar is not your average sales webinar or feature webinar. It's not about the competition. It's not about who's got more features or less features or the most features. It's all about system integration and the features we offer to make it easier to specify Audio-Technica wireless, to justify Audio-Technica wireless, as well as integrate it into systems. It's not about making things more complicated as they already are. But let's face it, in the real world of system integration, some customer requests or some consultant requests sound very easy, but they are not. They are not trivial, and we always try to offer the best solution and to make the customer happy and to make it easy to specify Audio-Technica as well as to integrate it. So wireless used to be an edge device. That means there was some audio video system somewhere, and at the very end of it, at the very edge, there were microphones. And over the years, microphones became wireless microphones, but they were still an edge device. Nowadays, wireless is moving much more to the core of the system and takes over functionality which used to be outside of the scope of microphones. So we have to think about holistic system design. We have to think about the overall picture. Audio-Technica also is much more nowadays than it used to be. It's much more than mic capsules. It's more about systems. So as I said, we as a company, and my position especially, is to support the integrators, support dealers and consultants to provide 100% customer success. So you can call me a customer success manager if you want. And of course, we have also we can and we should talk about business. So there is a strategic advantage to using Audio-Technica. And for in many markets, there is a very strict tender process. So you have to have certain features, and if we have certain features and the competition does not, this gives us and also you as our Audio-Technica partner a strategic advantage. So this is not only about technology, it's also about business and sales opportunities. I will present you a couple of extra features which you might not be aware of. And I invite you to do your own homework by thinking about a real-world application for each of the following features. None of these features is just here to be there. It's here to solve a problem, to solve a customer request. And so it might be a nice quiz for you and your colleagues within your teams to talk about what kind of customer, what kind of application could really benefit from these features. So let's dive in. The first of these features is called multi-TX for the System Pro, and a similar feature which is called multi-registration for the ESW. It's not the same thing, but it's similar. So let's dive in. What is this? What's this good for? In the old days, that means in the analog days, in the UHF days, there was one huge problem. You could never ever use two microphones on any one frequency. So if you have one microphone at one frequency and switch on another microphone at the very same frequency, chaos breaks out, and most of the time none of these microphones work. So two microphones on one frequency cause chaos. However, there are certain applications where people would like to use this because people want flexibility. They might say, let's say in my hotel, in my boardroom, four channels of wireless microphones are totally enough. It's way too complex and my people can't handle it to have, let's say, 8 or 10 or 20 channels. So 4 are more than enough. But we don't know if we need 4 handhelds or 4 gooseneck microphones or a mixture or this and that. So 4 microphones at any time are totally okay. But we need to have more flexibility than with the typical analog UHF systems. And as I said, systems must be user-friendly. They shouldn't be too complicated. And we all know the bigger the channel count is, the bigger the audio DSP must be, and the more complex it's overall. So neither the user or the more than often not very technically skilled so-called in-house technician, I'm thinking about hotel rooms or training centers, we need an easy solution and a workable solution. So our solution to the problem is multi-TX. What does it mean? We can pair up to 4 different microphones to any one channel. So we can have on channel 1 a gooseneck, a belt pack with a headset, a handheld microphone and or a boundary microphone. Or we can have on one channel 2 handheld microphones. We can totally mix and match. So in a 4-channel System 20 Pro receiver, we can pair, and let's call it pairing, up to 16 microphones. So we can have on each channel all 4 different kinds or types of microphones. There are 2 use cases, primary use cases for this, but I invite you to think about different use cases. Then primary use case number 1 is definitely to have different microphone types to choose from. So as I said, I might have 4 handhelds and 4 gooseneck microphones, and depending on which I switch on at the beginning, this microphone takes over. So take a look at the picture. Here is TX1 and TX2, and this is all about channel 1, let's say. We can have a handheld on TX1 and then a belt pack with a headset on TX2. And depending which transmitter I power on earlier, this one will get the channel. And the other one will not interfere. So even if you take out the other microphone from the drawer and try to switch it on, you can switch it on, but it will not cause any trouble because it will not be able to pair as the channel is already busy. And use case number 2 might be to have a spare microphone. So you might have 2 microphones of the same type, let's say 2 gooseneck microphones for the president. And if the microphone 1 goes out, maybe because the battery runs out of juice, you can simply switch on the second one. There's a business opportunity, of course, because for the first time ever, we can sell, or the customer can buy, microphones and receivers independently. So we can sell maybe 1 receiver frame, which, as you know, in the System 20 Pro has up to 4 channels, but can sell or deliver 8 microphones. And after a while, people might come to the conclusion that, yeah, it's nice and it was a good idea, but we actually need both types to work at the same time. So we need more channels. So you can simply come back later and upgrade the system with a second receiver frame and then repair the microphones to use all of them simultaneously. All it takes is simply repairing. So what used to be, let's say, TX2 on the first channel is now TX1 on the fifth channel or the sixth channel, something like this. So that for the first time ever, we can independently deliver microphone transmitters and receivers. That's a very, very flexible way of expanding systems, of doing an upgrade sale, of doing a phased rollout. So it's very, very a handy feature. With multi-TX, there comes a whole lot of extra benefits. The receiver knows which one of the four is currently on at a channel. So it even knows, that doesn't only know what type of microphone it is, it also knows the serial number. So a control system, your AMX, Extron, Crestron, whatever, your control system, your QSys, your control system could also access this feature. We provide this to the external control system. So that a very fancy control system could switch DSP settings like EQs or something like this, depending on which microphone is in use. Or the control system could be aware of the fact that the primary mic is gone and now the system runs on the backup microphone or similar things. I invite you to think about it, about the possibility of this. And a very important and very nice application is that large-scale users like big training rooms, universities and these kind of applications, they can track which type of microphones are really getting used. So think about a field test. You hand out System 20 Pro to customers and you deliver a headset microphone and a handset and a handheld. And you basically offer to the end user both of them. And you track basically which one the customer chooses. So does the customer take the handheld or does he take the headset? So for large-scale customers, they can basically run field tests before standardizing. And to make it a really worthwhile and fully functional feature, we can offer this directly in IT format. As you might be aware, we have a feature called syslog in the receiver, which directly sends this kind of information to the IT guys. Because one thing I want to make you aware of is we as Audio-Technica and you as partners, you might or most likely talk to an audio-video guy at the customer. But the boss of the AV guy is most likely, and the boss of the AV guy is most likely IT. And as you know, IT guys love data, and we provide this hard data. We provide this data. What kind of microphone gets used the most? We offer all kinds of microphone. The end user is free to choose, and we simply log and provide this data directly to the IT guys so they can make their conclusions. And this is not theory. This is really happening as we speak in some large-scale users, mainly education, mainly universities, where they really want to know what kind of microphones are getting used. If we move from System 20 Pro up to the ESW, as you might think of already, ESW is much more capable, and we have additional features. We can do this not only on a per channel basis, we can actually do this on sets of transmitters. So per receiver, as you know, the ESW receiver has got 8 channels. We can switch receiver sets, and we can also control this. Whereas on the System 20 Pro, we only have the possibility of simply waiting which kind of microphone, which type the user switches on first, because switching on first gets the channel. We can here dynamically enable and disable different microphones. So think about this on here. We might have in the first so-called transmitter set 8 gooseneck microphones. On the second set, we might have 4 handhelds. And we can basically dynamically switch between these transmitter sets. That means when the transmitter set 1 would be active, then only gooseneck types would be allowed to be switched on and would pair, and handheld, although you can switch it on first, it will not get a channel. The channel 1 to 4 will wait for the goosenecks to be powered up. And to make it even more complex, you can even store these kind of settings in a preset directly within the receiver, and an external control system or a preset from an Audio-Technica smart mixer can dynamically switch between these presets, so it can dynamically enable certain microphone types. Think about this in the lower left to you. In the preset 1 is basically having 8 channels with 4 goosenecks and 4 handhelds, and preset 2 might maybe disable 2 of these 4 handhelds and enable 2 belt packs with, let's say, headset or lavalier microphones. So we have all the freedom to have many more microphones than you have receiving channels, and dynamically switch between them. This makes really sense in flexible spaces, in high impact spaces, where you might have a board meeting in the morning, you might have an open discussion after lunch, and you don't have the luxury to run around and basically collect microphones and switch them on and off. As you might know, ESW microphones have extremely long battery life, so 20 hours, 25 hours. You basically switch on all the microphones in the morning, and then the rest is basically done in software. You kick out microphones, you re-enable microphones. You can all do this on the fly without physically touching the microphones. That's a super cool feature, and as far as I know, no other supplier of wireless microphones is able to do these kind of things. That's really a huge feature for the ESW. Another exclusive to the ESW is roaming. Roaming, you might know the term from your mobile phone, is very nice, because you have to think about how to do it without this feature. When you have widespread wireless, that means, let's say, in a big conference hall or in a fairground or something like this, and where really huge spaces. When you do it with analog or with traditional wireless microphones, you have really a so-called antenna forest. Lots of antennas, lots of B and C cable, coax cables, splitters, combiners, all this basically old, I wouldn't call it old technology, but actually it is. And let's be real, in today's building technologies, you don't make friends when you demand your own special cables to be run from one end of the building to the other one. Nowadays, all cables have to be Cat cables, and you either use the Cat cables which are already there, or you won't get the opportunity, and it will cost a fortune basically to run your own cables. I'm not talking about network in particular, but just Cat cables. The feature to tackle this this challenge is called ESW roaming. Just think about that up to 5 ESW receivers, the Dante version, form a roaming group. So they basically do have the very same configuration. They are like twins. They're like siblings. So up to 5 of them form one roaming group. You can even have more of one roaming group in any one space. So you could have, for example, I don't know, you could have 6 R4180 Dante receivers. 3 form group A, and the 3 other form group B, and they don't know of each other, and they work independently. When you switch on an TX, it will look for the best antenna, so where the most likely the closest one, but not necessarily where the best signal is, and it will pair with this antenna. As already mentioned, this works only for the Dante version, which is not really a problem, because the Link version or Link as a technology is mostly an in-room solution, and you hardly run Link cables around the building. Although you can, because the link itself is also capable of being transmitted to over 100 meters like a normal Ethernet cable would be. But this feature works only for the Dante version. So the opportunity is basically to cover a huge exhibition hall or a conference center or factory buildings, and you basically mount different antennas at strategic points in the room, and you basically actually don't care that much to which antenna the microphone actually connects to, because you basically pick them all over or off from the Dante network and you don't care. Or, of course, you can have different systems for different antennas. So, for example, a tour guide might walk through factory buildings and enter a factory building, switching on his microphone and talking to the local loudspeaker system, and then on moving to a different building or to a different floor, maybe briefly switching off the receiver or not switching it off at all, and moving out of the reception area of one antenna into the reception area of the other, and basically automatically and dynamically connects to the new system. As I said, up to 5 microphones or up to 5 receivers can be in any one roaming group. So the microphone itself will connect to any of them. How it's done? Basically, you have in the setup, you have 2 features or 3 features. Basically it's the roaming mode, you can switch it on and off, and then you have the so-called RF power and roaming threshold. What does this mean? It's quite easy. You define a roaming threshold, and if the microphone comes in weaker than the threshold, the antenna simply kicks it out. So think about, you have a wireless microphone, you move out of the reception area, the signal gets weaker and weaker and weaker, and then at a predefinable level, the antenna basically says goodbye, I kick you out, which basically forces the microphone to basically start searching again for the next best receiver. And the idea is, and the design is, that by now the user has moved much closer to another antenna than the distance is to the receiver he just left. So the idea is basically when the user moves or switches on the microphone after having moved, that the other antenna, the other 4180, has a much stronger signal, and it will basically jump over to this. To make it even easier, you can limit RF power. ESW is DECT based, as you might know, and DECT can be pretty far-reaching. It's surprisingly good in reaching huge distances, which is basically not what you want maybe in this. You don't want the microphone to still be connected to the one antenna which is in the other building. So you limit basically the RF power, you make it weaker by design, so the possibility that the microphone will switch over to another antenna, to another 48 or 80, is higher. So in systems commissioning, play around with these 2 parameters and you will get a very good results. Watch out, this roaming is not seamless. It's not seamless like you have maybe in a mobile phone. It takes a couple of seconds. I would say 5 to 10 seconds. So as on the conservative side, it takes up to 10 seconds. That means it's not meant to be one guy running around and being always connected. It's meant to work here or work there. It doesn't matter too much whether the microphone is switched off in between or not, but it's certainly helpful if the microphone is switched off and then repair to the other one. So conclusion, up to 5 antennas work in a group, and any microphone, and this is on a per channel basis. So every microphone jumps from one receiver to another one. It's not all 8 of them. If you use 8 microphones, each microphone basically does its own roaming. Other than it's not seamless, The reason for this is simply because of the built-in encryption. It takes some time to basically calculate new encryption keys, and for the reason that because of the encryption, it takes a couple of seconds. Still, nevertheless, it's a very, very useful feature, and it's really, really used more and more to cover huge spaces like trade show, fairgrounds, big conference halls, and something like this, where you might have a press conference at one day at one end of the hall and the other day on the other side of the hall. And you don't always want to roll around cases. You simply mount a multitude of antennas and basically pick your signal from the Dante network. That's ESW roaming. But it doesn't stop here. We have more and even more exotic and more special goodies. I want to remind you that both System 22 and ESW have very nice provisioning features. You know, the old way basically is you either have tiny displays and tiny buttons, and you have to do the setup directly on the microphone, or the more modern, but still not really super high-tech version is to do it on the receiver and then sync it via infrared windows. Both can be a little bit fiddly, and there is thankfully a better way. And the better way is, for example, in ESW, that the configuration is loaded via the chargers. As you know, the chargers are networked in the ESW, and so we have over the network. You simply put a microphone into the charger, and the configuration, that means high pass filter, gain of the microphone capsule, does the mute button work or is it disabled, and all these local to the transmitter features are being commissioned via the network. On the System 20 Pro, it's even easier. The configuration is loaded via the wireless link, so it's really over the air. For ESW, you need to have the network chargers for commissioning. On the System 20 Pro, the chargers, as you know, are optional. So basically, all the configuration is done from the receiver, over the network, over the wireless link to the microphone. And this might not sound like much, but actually it is, because there are some side effects you might have not thought about, but they are very handy and they come in very handy. First of all, TX and RX form one signal from one system. That means there is nothing the receiver doesn't know and only the transmitter knows. So it's one system, and you can have very nice functionality with this, because that means you can roll out changes or first-time provisioning microphones over the network. If the System 20 Pro receiver is networked, you can basically change the configuration of the wireless microphone during operation. So you can even think about dynamic automation. You could dynamically change the mute button behavior in System 20 or ESW. And we'll come back to this later. So no need to basically physically grab the microphone. You can do it over the network. ESW, simply put it back to the charging station, or in System 20 Pro, you don't even have to do this because it's dynamically over the air. You can really do fancy stuff with this when you're not limited to physically grab the microphone anymore. And one important aspect is also for doing system documentation. More often than not in the past, system integrators did not document the settings of the transmitters. Did he switch on high pass filter? What kind of gain did he have? And these kind of things. Collecting all settings from the receiver, because the receiver knows all the settings, makes system documentation really, really easy and totally complete. And this is very important, at least we think it's important for proper system integration and for offering system documentation for the end user, but also should a change or a replacement be needed. Yet another feature is people often ask me, why do we have this DSP in the System 20 Pro? As you hopefully know, we have a mixer, 4-channel DSP mixer in the System 20 Pro receiver, as well as equalizers and compressor limiters, and a very, very well full-featured DSP. And there are reasons for this, and one of the reasons is boxes like this, a so-called presentation switcher, an AV switcher. They are very powerful on the video side, as you see lots of HDMI inputs and outputs and analog audio and twisted pair receivers and USB and all these kind of things. But on the audio side, they are quite often quite, let's say, minimal. They mostly have only 1 or 2 microphone inputs at best, and more often than not, they have no audio features whatsoever. They might have a volume control, but that's about it. There is no compressor limiter, no equalizer, no nothing. So as a typical audio guy, you definitely want to have some tools for tweaking the audio, for making the user sound better. So more often than not, people use an external audio DSP, a smaller audio DSP, just for summing, let's say, 4 microphones into one and doing some EQ. And it's neither cheap nor is it sexy. And because the other option would be to say, yeah, dear end customer, it's the way it is. You have got maximum 2 microphones and you can only make it louder or less loud, and that's about it, because this box doesn't offer any more functionality. So we thought about this problem, and as you can imagine, there are hundreds of thousands of presentation switches from all different manufacturers being sold each year. So we thought about this, say, oh, why don't we use this? Why don't we do this already in the System 20 Pro receiver? So, and this was basically the reason why we included a full-featured audio DSP within the receiver box. That's handy because it's using less rack space, because it's built in the wireless receiver, less complexity, less IP addresses, less wiring, and also it's most likely way more inexpensive. Because for the price of the DSP, which is built in the System 20 Pro receiver, you will hardly get an audio DSP, and fully remote controllable DSP, might I say, because as you know, System 20 Pro receiver has got IP control for external control systems, for PCs, for Stream Decks or whatever, and you have access to all these parameters. And audio DSPs are costing mostly more than the whole wireless receiver. So the customer really saves money, he saves rack space and complexity overall. So this is a very handy feature to have the audio DSP directly within the wireless receiver. As far as I know, nobody else is doing it that way. So as you hopefully see by now, we really thought about the System 20 Pro receiver and the whole system to solve real-world challenges. It's really, we thought about what applications are needed, what functionality is needed in the system, and who is doing it best. Best means with the least rack space, at the least cost, but with the best flexibility. So we included this functionality directly in the receiver, as all the other functions. So we are now diving deep in system integration, and this is my home turf. I'm coming from the big scale system integration, for the complex system integration, so bear with me. We have some other little features and funny things built into the System 20. If you have multiple 1440 receivers, so more than one receiver frame, as we call it, from System 20, then we have these link cables, and these link cables do a lot. They sync all these radio frequency modules, and they also tunnel the IP remote control. So if you have up to 5 receiver frames, means up to 20 wireless channels, you only need one switch port on the network and only one IP address. because the first receiver will act as a master, so to say, and the control system or PC or our own wireless manager software will see all the other receiver frames under the same IP address but with a different network address. So the same IP address, the same physical one single network cable for up to 5 frames, equaling 10 channels in standard mode or 20 channels in HD mode. That's very handy, less cables, less complexity. We do this very same thing on the charger side, as you might be aware. Only one network connection, only one power supply for up to 10 slots. That means 5 dual slot chargers on the System 20 Pro. On the ESW, it's 8 channels. You can also mix and match on the ESW between the Charger 4 and the Charger 5. So it's 8 slots or 8 microphones on the ESW and up to 10 for the System 20 Pro chargers. So that means the Charger 3A and 3AN. Very handy, less complexity, less cabling, less possibilities for wiring errors. A very handy feature and often overlooked is the System 20 Pro receiver can display an QR code, and if you scan this QR code with your mobile phone, it links you directly to an up-to-date online manual, and it's even smart enough to detect your language. So for example, if I have my mobile phone to German language, there comes an online manual in German. And we provide quite a few different languages for this up-to-date online manual. So no need to Google around, no need to start your notebook or something like this. Simply walk up to the receiver, present your mobile phone to the QR code and have up-to-date online manuals. It's a tiny feature, but it's a very helpful feature. As you most likely be aware, System 20 Pro transmit bidirectionally. It means the TX or the microphone transmit to the receiver, but also the receiver sends information back over the wireless link to the microphone. That's pretty unique doing it that way, but this allows us different tricks or functionality. We already talked about the over-the-air config. This wouldn't be possible if there wouldn't be a communication channel from the receiver back to the transmitter. We do over-the-air config, so it's a bidirectional link. And super extra huge feature, and which is totally overlooked very often, is the so-called auto timeout. Bear with me. If the microphone knows when the receiver is switched on, because they're constantly talking, it also notices when the receiver is switched off. So a typical microphone transmitting only one way is never aware of the status of the receiver. But the System 20 Pro, if you switch off the receiver, the microphone basically gets orphaned, doesn't have a receiver to talk to, and if you enable it, simply will power down. So this is a super huge feature because you basically prevent, when you switch off the system, that the microphones run out of battery. You maybe set this to 10 minutes. When somebody switches off the main system, many people have key systems where the, let's say, lecturer in the university comes in with the key and powers on the system and powers off the system. So when he powers off the system, but forgets to switch off the microphone or replacing it back to the charger, it doesn't matter, because after 10 minutes or 60 minutes, whatever you choose, the microphone will simply power down and will power off itself, saving battery. And to make this really worthwhile, we even thought about on the receiver side. So on many wireless receivers, when you basically switch them on, or when the power supply returns, your 230 volts or whatever you have in your region, you have to press a start button, or you have to press a power on button or something like this. With the System 20 Pro receiver, it basically auto restarts, and it comes back to the exact same status it was before you took away the mains. So you can, with System 20 Pro, basically have a key switch and hard power it off and on by removing and applying main supply. Compare this to different other units and other vendors and other products. This is a very, very nice feature for many vertical markets, mainly education, schools, universities, large-scale training centers. And we can, since we have a bidirectional link or a return channel, as I want to call it, we can do some remote mutes for forming some kind of mini wireless conferencing systems. I will come back to this feature, remote mute, in the second part of my presentation. And also we have a nifty little feature which is called Identify. So when you're working away in Wireless Manager and you have to cope with, let's say, 10, 15 microphones, it can get messy. So what kind of microphone I'm actually adjusting and setting up now. So you can basically from Wireless Manager simply hit Identify, and the wireless microphone, there is a LED on it, will blink, so you exactly know which one. Think about, you have, let's say, ESW or System 20 Pro, you have 10 goosenecks on one huge table, and you simply are lost which microphone is it now I'm adjusting. And with this Identify feature, you can basically make this blink. It's very noticeable, but it's not super obvious to the general public. So you can even do it during an event, maybe. You can also have this remote control. You might be even do it. You can even do it from, let's say, a Stream Deck or something like this from your control system to make a brief indication which microphone is currently the one I'm looking for. All this is only possible because we have this bidirectional link. So I talked a lot, there was a lot going back and forth between System 20 Pro and ESW. As you know, these two are both meant for mainly fixed installs, but they are pretty different. But both of them are very important and both have a very, very strong position in their respective market fields. The most obvious difference is a technical one. The System 20 Pro works on the 2.4 gigahertz so-called ISM band, whereas the ESW works on the DECT band. The ESW has a much lower entry price and also therefore a lower per channel price. This doesn't mean that the ESW is expensive. It only means that it's much more capable, much more scalable. And if you consider all this, the ESW is very affordable in the market. So we are very competitive for both the System 20 Pro as well as the ESW. If you like, I invite you to do your own homework. Calculate your price in your local currency for the System 20 Pro with 2 or 4 channels, or an 8-channel ESW system, both in Link and Dante. For the ESW, you will see the ESW and Link version, Audio-Technica Link, is significantly less expensive than the Dante version. So, as I said, the System 20 Pro, much lower entry price. You can start much smaller with 2 channels, whereas the smallest receiver for the ESW is the 4180, which is an 8-channel receiver. As I said, the ESW scales massively higher. The cost for this, and there is nothing to hide here, is significantly higher latency. So the ESW is a voice-only, a speech-only system. It's not about the audio quality, it's about the latency. You basically cannot sing or play an instrument over ESW, and this is not about the audio quality. The audio quality is more than good enough. It's simply about the latency. So the ESW, we can scale up to 48 channels, 96 channels, really huge systems, whereas the System 20 Pro has about 10 to 20 channels at max. So the System 20 Pro, since it has a super slow latency, 3 milliseconds, which is super competitive, is universal. You can also use it for light stage and music use. What do I mean with light? Yeah, you have to be aware that there is the System 20 Pro as an economy system does not have a metal housing for the handheld, does not have changeable capsules and these kind of things. What let's say a System 3000 or a System 3000 digital, our stage wireless systems would offer. But as in the multi-purpose hall, where there is once in a while somebody sings a happy birthday or something like this, you certainly can, most certainly can use the System 20 Pro for light stage use. I simply wouldn't go on tour with the System 20 Pro for the mentioned reasons, but audio-wise, it's brilliant, as is the ESW. The ESW is only available with digital audio output. So this basically demands that your whole infrastructure is also built for digital audio, whereas the System 20 Pro has analog outputs and you can simply hook up any system you want. As you are aware, the ESW receiver is available with Dante ES67 version or with the Audio-Technica Link version. The Link version offers a single cable solution. You directly hook it up to the Audio-Technica smart mixers. As you have a single cat cable connecting many channels directly into an Audio-Technica smart mixer. So you have minimum effort and basically very easy and very inexpensive infrastructure to make a pure Audio-Technica solution. I don't want to go into much detail, but the early birds might have heard about product announcements from today from Audio-Technica Japan. Watch this space. We might announce something very shortly also in Europe about some very interesting new products. Think about a pure Audio-Technica solution. We got microphones, we got smart mixers, and I leave it up to your creativity and imagination what's currently missing to have a full Audio-Technica solution. It's not that difficult, so you won't win any prize. Just be a little bit patient and you will have a great product announcement. It happens today, or happened today, this early morning, local Japanese time from Audio-Technica, and you will hear an announcement very shortly in the EMEA region. The differences are also that in the ESW we have a built-in microphone, which is super handy. So teachers or trainers can simply take the lanyard and put it over their neck and don't need to wear a lavalier microphone or a headset. I personally would like to also see this on the System 20 Pro, by the way, but maybe will come anytime in the future. Right now it's an exclusive feature to the ESW. ESW offers roaming, we talked about this. ESW is zero rack space, yeah? You have a receiver on the wall and that's it. Link comes out, or the Technical Link comes out, or Dante comes out, or AS67 comes out, but you don't need any rack space for ESW, which can be very handy if you have just a tiny cabinet and no real 19-inch rack to put audio gear in. The ESW offering so many channels, as I said, up to 96 channels, we might learn a few software tricks in the future to make it even more useful. So I call the System 20 Pro a universal, a very inexpensive universal wireless system, whereas the ESW is application specific. That means nobody simply unpacks an ESW and switches it on. ESW, there are some certain features you can enable, you can disable. It's really application specific. Whereas the System 20 Pro can be a very easy wireless system, you simply unpack it, switch it on. The two-channel systems pairs are coming prepared. You don't have to do anything. You simply power it on and it works. With ESW, as you know, you need the charges, you need the network, and you need the commissioning process. But let's not forget, there are many, many use cases when neither of the two are perfect. So neither System 20 Pro or ESW is perfect. So we still offer, of course, and will also offer in the future, UHF, what we call performance audio wireless systems, mainly the 3000 and 3000 digital. They are for music, they are for on-stage use, they are for applications where UHF is still the best. So we will not replace these systems with ESW or System 20 Pro, so they will still be there, and there will also come new products for this category. For sure, there is a business case and a use case for UHF. No matter what the technology of the wireless is, we have a certain feature set which is there on all or almost all the recent wireless systems. First, and for me most important, is so-called real-time clock with a network sync. When you have a log file, or when the system collects a log file, it's simply completely unusable if you don't know the date and time when things happened. So a log file is good, but only if the correct time is there. So make use of it. Simply enter NTP time sync. In a bigger buildings, there's always a time server on hand, and then all of a sudden, basically automatically, the time will be correct, the date, and log files will be worthwhile. I briefly talked about the syslog. We have the syslog feature, which is basically nothing more, nothing less than we are talking to the IT guys in their native language. They might even have a syslog server already in their network, most likely. So we simply switch it on and we send all the log file, which we collect locally within the boxes, to them. And they can do usage analysis, they can make real-time ticket generation. So whenever there's an error from the receiver or a low battery warning or something like this, then they automatically generate the support ticket. Or they may simply collect log files and to make, analysis about usage. Which microphones have been used for how long, during what time of the day, and these kind of things. Syslog, nothing complicated on our side. We simply switch it off. We simply switch it on or off, and as soon as we switch it on, our systems send out the information to a local syslog server, and this is all we need to know. We have full IP control. That means we can have the custom control. Users can make monitoring solution. Everything is available via IP control. You don't have to start from scratch. We have many different platforms where we deliver plugins. We have partnerships with all the big industry players, be it QEC, be it Crestron, Extron, Ava cameras, whatsoever. And there is a big web page from the colleagues from Audio-Technica USA, where all these alliances and partnerships are listed and up to date. If you have any question about this, don't hesitate contacting me. So this would be part one. I would directly jump over to part two, if you don't mind, and would talk a little bit in more detail about features which are called external or remote mute. This is mainly about the system engineered wireless system, the ESW system, but a few things also apply to the System 20 Pro, and I will let you know afterwards what is only for the ESW and what is also for the System 20 Pro. But this is now a real system integration. This is now the real deal, more complex systems, and this is more often than not. This means ESW and not System 20 Pro. Let's start at the beginning. A mute button on a wireless microphone, and we are talking specifically now here for goosenecks and boundary microphones. So we're not talking about handheld with sliding switches. We're talking about gooseneck microphones and boundary microphones. Typically, when you mute the microphone, then the wireless link stays active, but there is no audio being sent. So you simply send over basically silence over the wireless link. Basically that means that the audio is muted within the microphone, within the transmitter. There's the wireless transmitter, you mute the microphone, and the wireless link is still there. The receiver still receives something, but it's silent. That might not be interesting to the end user at all, but we as systems designers and commissioners and system integrators, we have to think about if this is really the thing which should happen. Is it beneficial to my system design, this behavior, or could it cause trouble? And the answer is, there are many different use cases where this is not the intended behavior of the LEDs and or the mute function itself. Consider an event where ESW is used and there is a technician. The local mute button might be disabled, so the problem isn't there at all, or the technician wants to have a possibility of overruling. So might be the president of the meeting is nervous and fiddles around on the microphone and accidentally mutes the microphone. The technician simply wants to re-enable the microphone without running to the stage. So an external control system, an external operator should be able to mute and unmute the mic, or as well might temporarily disable the microphone mute, local microphone mute on the microphone. And of course, this also must be indicated on the microphone itself. Just consider that the operator switches on or off a microphone, but the user in front of the microphone has no clue. Then you see always this popping the microphone or coughing into the microphone, or is this on, is this not on? That's lousy. So we need to have indication. The typical applications for this is basically when multiple wireless microphones form some form of mini conferencing systems. As I said, the microphones should no matter where the system is being muted, should all indicate it. So basically when it's switched on from the operator console, it should also be switched on and indicating to the microphone, as well as when the operator disables or mutes the microphone, it should also mute the microphone. As you can imagine, this works only with ESW because it's the radio link is bidirectional. Without the bidirectional link, without the back channel and return channel, so to say, all this wouldn't be possible. In the past, people often said this can't be done with wireless. You have to use a wired microphone for this functionality. With ESW, we can simply say, of course it's possible. With ESW, with Audio-Technica Engineered Sound Wireless, this is possible. A very nice, very handy feature. If you want to go into details, you are invited to watch the recording and put the pause button on here. This is basically just a technical application, what's possible in the IP protocol. These 4.16, 42 are basically the chapter indication of the IP protocol, so it's easier for you to look it up. Basically, just look at the graphic up there. You have an external control device, controls the receiver, the R4180, and the receiver transmits the data wirelessly to the gooseneck and boundary microphone. So you see the possible commands. We can have a forced mute, we can have a forced unmute, and we can basically disable the local microphones button. So we can basically make let's say a forced unmute and then a forced remote on. Then basically the microphone is unmuted, it's on, and the user cannot switch it off. That would be 2 commands and only 2 commands. Our control system can also ask the microphone, are you on at the moment? Are you off? Or you might even play some extra tricks and do not touch the audio at all. You simply switch on the LED. So maybe you do not want to mute in the microphone, but the audio technician wants to mute on his mixing console. So you can also always pre-listen the receiver, but we indicate to the user via a green or a red LED whether the microphone is basically hot or not. So we can basically control the mute function within the microphone as well as the LED from remote. Yet another example, a little bit more complex system would be when we have a teleconferencing system, means a Teams meeting, Zoom meeting, whatever, telemedicine in a hospital environment, could be government application, whatever. The user, you see this sharp dressed guy here, wants to push the mute button. Yeah, he wants to control his own microphone, but for technical reasons, this muting should not be done within the microphone. I will explain to you in a minute why it's a bad idea to mute within the microphone. So this guy wants to mute his microphone and unmute his microphone, but the mute should not be done within the microphone. Instead, audio should be muted somewhere down the signal chain in an external DSP. So basically that means this local mute button in the ESW microphone should signal please mute to a third-party device. The third-party device could be an ATDM mixer or could be a QSys or whatever system. And then when this external audio DSP successfully muted or unmuted it, its mute status should be communicated back into the microphone to switch on or off or change the color of the LED. So in essence, the LED should be remote controlled independently of the audio by a third-party device. So we have 2 different functionalities. First, make the mute button not touching the local audio, but just signaling to some external device, please mute or unmute me. And the other one is we want remote control of the LED from a third-party device. As I said already, the user doesn't care at all where and how the signal is getting muted. The only thing he wants to do or wants to know is if I press this button, is my microphone muted, and do I see it's muted, and the other way around. So why do we want to have this? You might be aware of the term AEC, acoustic echo cancelling. And for an AEC, no matter whether it's our own in our smart mixers or a third-party ESC, doesn't matter at all. The AEC must constantly listen into the room. So if we would mute the microphone locally, we would stop sending a signal to the AEC, and this would mean the AEC is deaf for the time the microphone is muted. And this would bring in some artifacts when we unmute the microphone. Maybe the first word is being cut off, or you have some noise or something like this in the very first second or first 2 seconds until the AEC basically reestablishes operation. So we want to have a mute function which is the signal chain after the AEC. Just look at this block diagram from, I don't know where it is from, it could be from the small ATDM mixer. You have the AEC, the signal comes in from the left phase and low cut, and then you have the AEC, and after, much after the AEC, there is the mute function. So basically, when you unmute this channel within this mixer, the AEC will always see the signal. Now, think about when our microphone to the very left would simply stop sending a signal if we mute it locally within the microphone. It wouldn't make much sense because the AEC would be deaf and it would stop working. And when we re-enable the microphone, the AEC would be surprised and would produce some artifacts. Most likely, the audio would not be perfect for the first 1 to 2 seconds after the AEC is doing its so-called reconverging. Reconverging is basically the process the AEC does when things change suddenly. So the application is basically we disable the local mute in the ESW and we switch it over to remote mute. That means the button doesn't do anything locally within the microphone, it just indicates to the external control system. So you press the button, the mute button, and you unpress the mute button, but it doesn't do anything in the microphone, it just indicates to an external control system. So it works like this. The step 1, that is basically we send it only once. We could send a control mode setting. We set the microphone into the so-called remote mute mode. Means the button doesn't mute the microphone. This is basically what it does. A control system would track the mute button presses. In the above, it's point 1, remote mute station. Then remote mute start to step 2 in the graphic. The control system would mute the mixer or third-party DSP or Audio-Technica smart mixer. That's point 3 in the above graphics. And then 4 is the control system gets the info from the DSP. Yeah, the DSP said, yeah, I muted this channel. Mute notification, point 4. And then 5, the control system sends back to the microphone via the receiver over the remote return channel, set the LED to mute or unmute. So basically this is what it does. It's a control loop and it's totally independent of the audio. The audio is always sent from the wireless gooseneck via the ESW receiver into the mixer and into the AEC, which is in the mixer or third-party DSP. This audio channel is never interrupted. It's always on. The AEC for each microphone always sees the AEC, the audio signal. The AEC will never reconverge. It's always up to date. And as soon as you unmute the microphone, there is no sudden change in signal because for the AEC, it doesn't change anything. The AEC always was hearing the audio signal. This is an application. It may sound complicated, but actually it is not really, and it's totally doable with Audio-Technica ESW. That's ESW, ESW. This one is not available on the System 20 Pro. So this is a typical advanced control system for the ESW. And some behind the scenes info, let's call it that way. We are not doing this automatically within our ATDMs, maybe in the future. So currently this means we need to have an external control system. Could be a Crestron, could be whatever, a QSYS. In a QSYS, as you know, a Symmetrix DSP, you know there is an audio DSP and a control system in one single box. Basically, all it takes from the external side is an audio DSP with an AEC, and a mute function which is after the which is post AC. There is certain business impacts to them. As Audio-Technica, I or Audio-Technica salespeople or technicians are only responsible for the IP protocol. There's nothing we do on our own. We simply offer the possibility of doing this in the ASW. But it's a huge, huge help for the third-party DSP to provide significantly, and I really say significantly better AAC. It doesn't change the sound of our microphones at all, but I invite everybody, Audio-Technica people, as well as dealers, distributors, or end users in this call, to compare this feature set with any competitor, and you will see that Audio-Technica really have thought about this, about the whole system, about how a system should be controlled, how it should be designed, and hardly anyone has this feature or a feature in this complexity, but it's really important to make a system work perfectly. After all, we are talking about customer satisfaction, and this is one way for a technician having perfect customer satisfaction. So just as a conclusion, more or less, a typical normal wireless microphone is unidirectional, so the wireless microphone cannot receive commands. All these use cases and all the ones I talked about today, or pretty much all of them, depend on this so-called back channel. So with other vendors or with other wireless systems, that means you can't do it wirelessly because there is no back channel. You have to use a wired solution. With us, with ESW, you can all do these fancy tricks wirelessly because we're sending bidirectional over the air, and the wireless microphones can receive control data. To make things a little more visible, in ESW we have two independent mutes. One is the TX we talked about. That's basically before the audio hits the radio, so it's within the microphone. And another one is within the receiver, basically after receiving it, but before it's being sent out via Dante or Audio-Technica links. Both of them you can control with a control system. The one within the 4180 is a little bit dangerous because there is no LED indication. The above, if you don't disable it, you see it on the wireless microphone itself, whether it's muted or not. But the lower one is only controllable. It's also controllable, but could be a little dangerous because people tend to forget because they don't see a mute LEDs anywhere. Still, you can do it. Or what we just talked about, a third mute, you mute in an external device. You neither use this mute nor the other one, but use the third mute within an external audio DSP. So from a different perspective, you could say that the mute buttons and the LEDs are user interfaces to an overall system, and far, far more than just the mute button. You can do all kinds of things with it. You can do mute, you can also do other things. You could basically use the LED, make the LED blink to indicate that people talked already too long, you know, because the LED is user control. You can make it LED blink. You can switch off the LED when you want the other one to stop talking or whatever. So long story short, you can do lots and lots of integration with it. I promised you to say some word about System 20 Pro. As you know by now, it also transmits bidirectionally. We support a subset. If you remember the use case 1, the remote mute override, where the operator overrides the mute on the microphone, is fully supported with System 20 Pro. The other one with the mute loop, you remember the more complex use case 2, is only partially supported right now, which is not a big thing because this is really serious system integration. and this is normally not done via System 20 Pro. But you can do a lot of it still. For example, remote controlling the mute LEDs is fully possible also with System 20 Pro. Just a word to remind you, ESW means engineered sound wireless. So it's for engineered system, and the System 20 Pro is a multi-purpose wireless system. Long story short, I invite you to play with these features. If there is any question to it, ask it now or later. I'm pretty proud of Audio-Technica thinking so hard and so deeply about the whole system. As you might have seen, many of these features don't bring any benefit to Audio-Technica. They benefit the system integrator or the consultant to be able to do better systems, to design better systems, to make better systems, and to make the customer happy. This is what's the end, all of it. We're making a business out of it. And as a user, you might want to be assured that Audio-Technica thinks hard about you and your application. So that's the end for my presentation. I'll hand it back to Sandy, and maybe we have some questions.
Hi, Harald, and thank you very much for that very informative online seminar. Actually, there is not one question yet. So,
Everybody fall asleep.
I don't believe so, but maybe you explained everything like in such great detail that there is no questions. So, but anyway, I want to give the chance again to like all attendees to now put in any questions or even comments in the question and answer section if you want to do.
Or send me some hearts or
Or
applause.
yeah, some reactions. Oh, actually, there is now a post. The question is, if you received the presentation, you're going to receive the recording. So, but you can also reach out individually to us via email, and we surely can share something. Oh, I believe that was the question I just answered of that person who raised the hand. Yep. Anyone else? Any additional questions or comments? Not so far. There's someone mentioned that they still have end users saying that they don't want digital systems because it's not reliable as UHF.
You know, if people think it's a religion and take it religiously, then there's nothing we can do. Yeah, from a technical point of view, and I'm a communications engineer by education, I can assure you that digital systems are basically nowadays much more reliable. There is a main difference is that analog system basically get when you run into problems, they are becoming gradually worse and worse and worse and worse. And with digital, basically it stays perfect, then you almost fall off a cliff, so to say. But to say that analog systems are more reliable than digital is simply not true anymore. But you know, you can't help if this is the firm belief of a customer, then so be it. We are not missionaries, you know, that we cannot change this, but from a technical point of view, digital systems are by far more reliable these days because you have all these digital extra things to play with error correction and these kind of things.
Thank you. There is another comment with the System 10 Pro. There seems to be like several issues with the link between the receivers. Is that something you already faced with the System 20 Pro as well?
The System 20 Pro builds on top of the System 10, but I would say there are about 10 years of engineering in between. We are selling now, we are delivering System 20 Pro now for close to 9 months, 8 months, something like this. And we haven't had any bad feedback about this specific thing. So I consider this to be not an issue with System 20 Pro.
Then there is another question. How does the performance of the roaming mode in the ESW system compare to the multi-point functionality within the 3000 series?
It's comparable, but the main difference is that with the multi-point functionality in the 3000 series, you still have a lot of receivers and antennas and coax cable and this kind of things. With the ESW, you move all this into the digital domain, and you in the digital domain is basically much easier. And also when you do it on the Dante side, it's much easier to collect the microphones. But there are similar use cases, but there are still use cases where you would prefer the old way of doing it with the 3000 series, but it really depends on the application.
I hope that answered the question. Thank you, Harold. There is another one. So customers writing, they have an Audio-Technica wireless system, the ESW with like CHG4, with handheld and headset microphones. There is a little bit audible latency in the audio. Is there anything we could do about that? As far as I understand, the latency is from the microphones.
The ESW system is DECT based, and DECT is by design has a rather significant latency. I would say at very best, it's about 15 to 16 milliseconds at least, that's the reason why I said it's only for voice and mainly for teleconferencing. This latency is significantly higher than, let's say, stage wireless systems like the 3000 digital or the System 20 Pro. There isn't anything we can do about this. This is a part of the DECT technology, and it's the same also for other DECT-based units. In video conferencing applications, sometimes it's not even that bad because the latency of the video with all this video processing nowadays is also quite long. So for the typical application, large-scale video conferencing systems, shareholder meetings, these kind of things, a longer latency might even be beneficial for the lip sync. But yes, you're totally right. The DECT-based systems have much higher latency than any other comparable technologies.
Thank you. I hope that helps as well. There is another one. Do you know if there is something planned, like a possibility that the mute button will release the channel for an additional transmitter? For example, if you have a handheld transmitter and a backpack transmitter, and if they're on the same channel, as soon as you mute one of them, the other channel will start working in place. Do you know if
that would be possible with custom programming and a control system with the ESW today? Not with the System 20 Pro, but with fancy programming, you can do this with ESW today, because you basically can, with ESW, you can make the mute button doing simply an indication, and this indication would provide, I have to think about it and I have to double check it whether this also works for the handheld, because you asked specifically for the handheld. It will work for the boundary and gooseneck for sure. For the handheld, I have to double check. I'm not quite sure for the handheld, because we have a sliding switch and not a touch kind of switch.
Thank you. I hope that this is also answered by now. Is there any additional questions coming in? There is one more in the chat. How does the system handle coexistence when multiple System 20 Pro deployments are operating nearby, such as in a multi-room conference center?
As you know, System 20 Pro works on 2.4 gigahertz, which does not have a huge far-reaching technology. Like you might know it, your Wi-Fi at home. It's also after two walls, it's gone basically. So you have multiple access points. And similar with System 20 Pro, when you have let's say one or two walls between rooms, the System 20 Pros don't even know from each other. You know, it's like having multiple access points in different rooms. And normally there is enough spectrum available. So as long as you don't have, let's say, 14 channel here and 12 channel here and 14 channels there, it shouldn't be a problem. So you have a typical room with 4 to 8 channels here and 4 to 8 channels over there and 4 channels there. It shouldn't be really a problem because 2.4 doesn't reach that far. And it hasn't been a problem until now for such kind of rollouts.
Thank you, Harald. Is there anything else? Let me check. Not in the Q&A, but again in the chat. That's something I'm going to answer. You're going to receive an email quite soon, by latest beginning of next week, around that.
Google is your friend.
That's not answered by Google, but that was a answer on some friends not too far from here. What is the maximum transmission range of System 20 Pro that you are recommending, Harald?
Very good question. Very good question, because there is significant difference to UHF systems. For example, I would not recommend it going beyond 50 meters. Like Wi-Fi. Wi-Fi isn't great at big distances. So for example, if you want to have a wireless microphone on a sports arena or a sports car, a football field or something like this, where a presenter wants to walk around the whole football field or athletic field or something like this, I would not recommend 2.4. I would still go with a System 3000, because in UHF, because of the lower frequency, the range is much, much bigger. So System 20 Pro is up to 40, 50 meters in free field. Within buildings, I would say through one wall, like your typical Wi-Fi. So there's a limitation. System 20 Pro, I would not use it for big distances in outdoors. There, UHF is still the better choice.
Thank you. I do not see anything in addition coming in.
Looks we are perfectly on time.
We are perfectly on time. Well done, Harald. Thank you so much, Harald, for your time and all that information you shared with our customers, interested people, and distributors. That online seminar was recorded, and you should be able to access the recording. If not for any reason, please feel free to send me an email. I'm going to type in my email address within the chat field so you can copy and paste it. Again, thank you very much, Harald, for your time and all that information. Thank all of you for joining us this morning, afternoon, or evening, depending where you're placed, and have a lovely rest of the day.
Thank you. Take care.